Hi everyone, my name is Siddharth Deshpande and I'm here to present the last module capstone project of machine learning model which is here. So the project name is so the project name is basically health insurance cross-sell predictions. So first of all, let's start with the summary of the project. So what is the objective of the project? So the first objective of this building model is that how we reach out to the customer and convince them to take the vehicle insurance. So the data set is of the customers who have already taken the health insurance, and we have to reach out to the customer to take another insurance, that is a vehicle insurance. So this is our primary objective. So as we know that this is a business context, that like insurance is very periodic. Insurance is fundamentally risk sharing agreement where customer pay a periodic premium to protect themselves from a potential financial loss due to health, vehicle or other events. So the basic objective is to reach out to the customer and asking them to take the vehicle insurance. In this model, we have quite done few machine learning model things like first of all we have done a data pre-processing, exploratory data analysis. In the data pre-processing we have done handling missing values, encoding categorical features, scaling numerical features, etc. In exploratory data analysis also we have done on what factors that influence interest in the vehicle insurance. So we have discussed three models here: logistic regression, because as it is a classification problem, so we have used a logistic regression, a random forest classifier and XGBoost classifier. After that, we have used a model evaluation criteria, a confusion matrix, accuracies, precisions, recall, F1 score, etc. Also, we have done a hyperparameter tuning on the models, which also increases the accuracy of the model. Mm, So this is basically overall summary of this project. After that, this is my GitHub link. You can see the project. You see my project here. So what is the problem statements? The insurance company, which currently provides health insurance to a significant number of customers, is seeking to expand its offering by cross-selling vehicle insurance. So basically, company is seeking to expand its business by selling vehicle insurance. And to the same customer who have already bought a health insurance. However, not all the customers are willing to take the vehicle insurance, as they have already have one insurance with that company, that is health insurance. So we not blindly targeting the entire customer. We just we just observe the data. We just observe the customers want how what the customer wants something from us. Then after we approach them. So to optimize their outreach, the company requires a predictive model that can accurately identify which of the existing health insurance policyholders are most likely to be interested in purchasing vehicle insurance. So we have to build the model which states that number of policy what number of policy holders are interested to take the our vehicle insurance. So we have to outreach that customers. So the prediction will allow the company to focus its resources on a high probability customers, which improves the conversion rates, maximize business growth. So that's all our problem statement, and that's what company wants from the data scientist to grow their business. Let's begin. First of all, to know your data, and first of all to import libraries, which is all essential libraries used in this project or in this model building. So NumPy, Pandas, Matplotlib, Cvon, and for the train test plate from sklearn we have import train test plates, standard scalar, one hot encode from for encoding. One hot encoder is a library, label encoder, random oversampler for imbalanced data, logistic regression for model building, random forest classifier for model building, XGB classifier, extra T's classifier is for the feature selections basically. Now, for evaluation metrics, accuracy score, confusion metrics, classification report, ROC curve, like that. So we have uploaded the essential libraries. Now dataset loading. So we have mount the Google Drive, and we just from pd.read underscore csv, we just upload the data. Now first the dataset first view, which have columns like ID, gender, age, driving license, random code, previously insured, vehicle age, vehicle damage, annual premium, policy sales channel, vintage response. So this response, this response is our final call target column basically. The response have two values, that is 1 or 0. 1 is for the customer response, the customer purchased that vehicle insurance, and 0 means the customer did not purchase that vehicle insurance. Rest all is our independent variable, and response is our dependent variable. The data row contains 33,81,109 rows and 12 columns. Now data set rows and columns, so data.shape is the function. After that, the information data.info. So ID is a data type, gender has object data type, age, driving license, region code, previously insured, vehicle damage, annual premium. So this is our information regarding all the columns. Now duplicate values. There is luckily we have no duplicate values in this column, in this data set. Also, we are so lucky that there is no missing values in the data set, so we don't have to do the data wrangling code where we just compute the missing values or compute the duplicate values, etc. Now let's so there is no null values present here, so the heat map is so the heat map is null. So far, we have learned about the dataset is that there are 3,81,109 rows and 12 columns. We don't have any null or duplicated values in our datasets. Our dependent feature, that is response, is a categorical column which have two values, that is 1 and 0. Now there are several numeric and categorical columns in the datasets. Understanding of variables. Variables is ID, gender, age, driving license, region code. Previously, that already we have discussed. Now data.describe, through describe function, which has got all the numerical columns, description of regarding the mean value, minimum value, maximum value, 70 median value, also maximum. So the maximum, we can see that the maximum age is of 85 and the minimum age is 20 and median value is 36. Most of the people are of age of 36. And annual premium, the maximum annual premium is 55,40,165. The minimum annual premium is 2,630. So this is all of describe this is all the description of the numerical data. Let's talk about the description of the variables. What variables actually in this dataset used? ID, that is a unique identifier for each customer in the dataset. Gender, the gender of the customer, which can be either male or female. So their gender is a categorical column which includes two values, that is male and female. Age is also the numeric value. Driving license also a numeric, it is a binary, like the indicate whether the customer holds a driving license or not. So the customer holds a driving license is representing a value of 1 and 0 for 0 for not holding the driving license. Region code, unique code representing the geographic region of the customer basically. Previously insured, this is basically important because this states that a variable indicating whether the customer already has vehicle insurance. The customer which have already a vehicle insurance, so the previously insured, so the value is 1. So the value is 1, and does not have previously insured, the value is 0. Now vehicle age. Vehicle age basically it categorized into a 3 column, that is from ranges between 1 to 2, greater than 2, or 0 to 1. So this is a again categorical column. Vehicle damage. If the vehicle has been damaged, for the customer. So the value should be one, otherwise no. Annual premium, the annual premium amount that the customer pays for the current health insurance policy. So this is basically a annual premium of current health insurance policy, which is a numeric value. Policy sales channel है. 11th column is vintage, the number of days the customer has been associated with the insurance company. So this is a vintage. Um, it states the stickiness of the customer with that company, like constantly. So the vintage tells you the number of days the customer has been associated with the insurance company. Lastly is the response, which is the target variable, which indicate the customer is interested in purchasing a vehicle insurance or not. So one for the interested and the zero for not interested. Now check for the unique values. So data.n unique is the function where we got to know that gender has two unique values, that is male and female. Age has 66 unique values. Driving license is 2. Region code is 53. Previously insured is 2. Vehicle age 3. Vehicle damage 2. Annual premium, like that. Now let's see the visualization of this data sets. So the first chart is count plot of response. Let's see how many responses are there. So we can see that this data is very highly imbalanced because most of the customers are not willing to take the vehicle insurance. Very less are interested in the taking the insurance. So why did you pick the specific type? For comparison of values of response column, that is our target variable. To get the what's the insight found from the chart, to get the information that how many are the positive responses present in the data set. Chart 2 is plot of willing males and females. Plot of willing males and females. So willing males are 61.1%, which who are willing to take the insurance, and females are 38.9%. This chart tells you that. After that, third chart is age versus response. So through this we can clearly see the age between 30 to 60 are quite interested in taking the insurance. Other rest are less interested in taking the insurance, and this is legitimate because most of the matured peoples are within this age age span, like 35 to 55 or 60. So they are more responsible regarding their vehicle, or they are more mature. So they are highly interested other than these people. After that, chart 4 is preference of previously insured people. So this chart states that who previously insured, who has previously take the vehicle insurance, are less likely to, are who have they. So this one represent previously insured. So who has previously insured vehicle, they are not not at all interested in taking the insurance right now. And those who are not previously insured vehicle insurance, so they are willing to take the vehicle insurance. This chart says that. Fifth chart is proportion of customer with a vehicle damage. So so proportion of customer with vehicle damage. So they are almost equal proportion of customer with vehicle damage. So this is a donut chart. 50.5% is customers with a vehicle damage, and 49.5% with a with no damage. Sixth chart is preferences of people owning driving license. So this is also very legitimate that the people having driving license are likely to interested in taking the insurance. Those don't have are not, very less or almost null. Pretty obvious that. So this is the response of owners based on the life of their cars. So the person or a customer who have a life of their car is 1 to 2 year of age are more likely to take the insurance. distribution of annual premium. So this is a distribution of annual premium, and through this it is pretty obvious that it is a highly right skewed data. So to avoid this skewness, we can also use the log transformation, because log transformation is very much helpful in the skewness of the data. And this is the box plot of the annual premium, where there is so much outliers in the annual premium column. So upcoming video, you can in the upcoming session you can see we how we handle the how we handle the outliers. So the ninth chart is a correlation heat map. So basically this is a relations between the variables, and we can clearly see that vehicle age and policy sales channels are quite relatable to each other. Also the vehicle damage and the response. If suppose vehicle damage is high, the response is also high, and the vehicle damage is low, the response is also low. Vehicle damage, vehicle age and policy sales channel also. Point to age and vehicle damage is also responsible some in some extent, up to some extent. 10th chart is of a pair plot. So this is the pair plot which tells you all the distribution of the graphs. The last but not the least is the vehicle damage across genders. So we can say that yes for the vehicle damage, no. So we can say that the damage is between 30 to 80. There is a damage of vehicle for the male, and for the female also that there is the same 30 to 40, 80 vehicle damage. So these all are the visualization for this data set. Now hypothesis it's time for the hypothesis testing. So hypothesis testing is something, basically we can test whether there is significant association between vehicle damage and response interest in insurance. So for first hypothesis testing, we have a null hypothesis, that is there is no associations between vehicle damage and response. And the alternative hypothesis is basically there is an association between vehicle damage and response. So to perform this hypothesis, we can use chi-square testing basically. So we have import these scipy.stats, and we have taken vehicle damage data response. We perform the chi-square chi-square test, and we have calculated that p-value is 0, chi value of chi is 2 is 47864.76, and so the answer is it rejected the null hypothesis. So there is a significant associations between vehicle damage and response, and this testing shows that also the proof that we have discussed in the heat map, that vehicle damage and response have a significant amount of relativity, that is of 0.35, that is the highest. So this is the hypothesis testing first test basically. Second test we have performed, of ANOVA test. Second test we have performed of ANOVA test, or no, independent test. So here we can test if the mean annual premium differs significantly between those interested or not interested in vehicle insurance. So so this test is basically for the annual premium difference. So the null hypothesis is the mean annual premium is the same for the both groups, yes and no. An alternative hypothesis, the mean annual premium is different for the two groups. So this is the testing, and we found that there is a p-value, significant p-value. So also rejected the null hypothesis. So the mean annual premium is significantly different between the two groups, that is yes or no. This is the t statistics, independent t-test. Third hypothesis testing is of ANOVA test, which means of continuous variable across more the two categories like vehicle age, etc. So the null hypothesis is the mean vintage is the same across different vehicle age categories. Failed to reject the null hypothesis. It means that no significant differences mean vintage across vehicle age groups. So this all is of hypothesis testing. And by the way, this name of this test is ANOVA test. We have selected ANOVA because it computes the means of continuous variable across multiple categories, making it suitable for testing difference across more than two groups. Now it's time for the feature engineering or data pre-processing. Since we don't have missing values, so we can't do anything here. After that, handling the outliers. Before handling the outliers, we just have to detect the outliers. So for the detection of the outliers, we must use the IQR, interquartile range method, basically. So we have written a function outliers, detect outliers. Q1 is the first quartile, Q3 is the third quartile range. 0.25, 0.7 percentile, basically formula of IQR is Q3 minus Q1. So the lower bound is basically Q1 minus 1.5 into IQR, and upper bound is Q3 plus 1.5 into IQR. So outliers is basically is lower is less the column which have less than lower bound, or the column which have greater than upper bound. So these are the outliers basically. So this is for the annual premium outliers. This is for the annual premium outliers, because we have only selected the annual premium column. Now for the all the numeric column using IQR, so the same function we have added. Now outliers detected. So driving license has 812 values which are close to the outliers, or which are outliers only. The annual premium is 10,320 outliers present, and 46,710 outliers in the response. So how to handle these outliers? How to handle these outliers? So by keeping the outliers, so cap outliers, the same method here. So data shape after the caping of outliers is 3,81,109 and 12 rows, same. So the best method to remove the outliers is the log transformation. Apply log transformation in that column, or that numerical column which have outliers, is the best way, because through this log transformation we can't we we the loss of the data is very less. The loss of the data is very much less, or almost nil. So we always use the log transformation to remove the outliers. Here we remove the outliers only. Now log transformation and caping outliers are the two best outliers detection, as there is no such data losses in the removal of outliers. After that, third is categorical encoding. We have seen the data set in that variable has a categorical variable also there, but our model are best in the numerical column. So we have to encode the categorical column into a numerical column, like gender, a vehicle age, vehicle damage, yes no to the 1 or 0. So we have used the label encoder. We can also use the one hot encoding, but label encoding is very much better than one hot encoding, because one hot encoding takes so much of space as compared to the label encoding. So label encoding data gender, label encoder dot fit transform data gender. After the encoding, we have done. So the data dot head is gender 1 1. So this is basically male, or 0 is for female. Driving license, region code, previously insured, vehicle damage, annual premium, same as that. Features. Now it's time for the feature selections for the model building. We know that our target variable is a response. So we are stored the target in the y variable. Y is equals to data of response, and x is equals to an x rest all the columns except the response column. So data dot draw of response, x is equals to 1. independent variable. After that, basically this is a feature importance. This tells you that extra t's classifier tells you that what are all the features are really important in this model building. So for feature important for the better visualizations, so we can clearly see driving license is doing nothing in our model building because it is not much as important in this data set. So we just remove driving license column from the X. So the X now has a column 10 because there's two column gone, that is Y depend target variable and driving license column. Now data scaling, you can clearly see annual premium is in the range of lakhs or thousands, and the gender is 1, also age is 44, and response is basically 1 0. So we have to scale these values between the -1 to 1, and the best method of scaling -1 to 1 or is min max scaling or some min max scaling basically. So we use standard scaler from sklearn library, and we just done the scaling of all the numerical columns. Annual premium, vintage, age, policy, sales channels. So we have minimized all the important, we have scaled all the important numerical columns here. Now, which method have you used to scale your data and why? So, standard z-score normalization because it is suitable for the logistic regression and support vector machine. We can also use min-max scaling but min-max scaling is suitable for the KNN algorithm, much more suitable for a KNN algorithm. And today we are using the logistic regression, random forest, etc. We also reduce the dimensionality of the features if there is a need. So in our case, there is no need to reduce the dimensions as age, annual premium, and vintage are not that much highly correlated. If the columns are much highly correlated with each other, then we think about the dimensionality reductions. So now, firstly, we check the imbalance of the data, and we know that there is an imbalance of the data because one is positive response is very less, that much of negative responses. So the count is for 46,710 are the which have positive response, and 3,34,399 is of negative response. So handling the imbalanced data set, we use random oversampling for the distribution of for the betterment of data set. For the betterment of the data set. Now the original data set shape is 3,81,109. After resample data set, our shape is 6,68,798. What technique did you use to handle? Okay. After that, uh, so what technique did you balances the classes by duplicating the minority class instance? It increases the representation of that class in the training set, improves model performance. For classification algorithm, balanced data set often leads to more robust models. So time for the splitting of the data. We have split the data into a four part train, test, y train, y test, x train, x test, y train, y test. So in the X train, we have given a 44 lakh 68,158 rows. In the X test shape, 2 lakh 6,000 2 lakh 640 rows. In the basically Y train for 4 lakh 68,158, and Y test is 2 lakh 6,040 again. In the feature selection, we have scalar equals to standard scalar and fit transform. we divide the test size is 30% and train size is 70%. Now it's time for the implementation of the model. So the implementation of the model, first model is of logistic regression. First model is logistic regression. Logistic regression is a classification algorithm, as this is a binary classification problem, which takes the input as one or zero, and which takes the input as independent variable and prints the output one or zero, either yes or no. Response is yes or no. So logistic regression is the best binary classification model, as it using a sigmoid function, 1 plus e to the power minus z, basically is the function of sigmoid, basically is the equation of this sigmoid function, which have value which have a threshold value, that is zero point 0.5. If the value is above the zero point 0.5, the answer is yes, and if the value is below the zero point 0.5, the answer is no. It just work upon the sigmoid function only. So here we just take the variable reg, logistic regression. We have fit the model and take the probability, and this all code is of evaluation metrics, accuracy, F1 score, recall, precision, EUC. So this is the answer of this model. Accuracy score of this model is 76% basically. F1 score is 82%. Recall score is 97%. It means that how many times our model how many times our model is predicting correct value. So this is precision score 70%. How many times our model is predicting correct response. So 70%. AUC is 83. But this model is quite less giving accuracy. It's giving very less, 78% basically. So this is a classification report where precision is of 1 is 98%, recall is 71, F1 score is 82. Support is this micro average, weighted average. Now this is now ROC curve of this model is like that. The purpose of the basically the ROC curve is at the 0.5. If the value is above the 0.5, no, yes. If the value is above the 0.5, it is a good model, and if it is not, it is a bad model. This is the confusion matrix of logistic regression. This is now we have done the hyperparameter tuning. So we can believe that hyperparameter tuning is increases the accuracy of the model, but after tuning, so we have used the grid search CV. We have used the grid search CV, and there is no change in the accuracy. So best is accuracy 78.78% basically. Now, second model is a random forest classifier. Random forest classifier basically is the best model in the whole model community. It basically it is basically a combination of different decision trees. So more than more decision tree combines to get the random forest. So basically random forest is a very powerful model we have used in here in this data set. Random forest classifier, y predict, x test, where accuracy RF, F1 RF, all the same thing. So the accuracy of random forest is 94%, which is quite good enough to believe in this model. F1 score is 95%, recall score is 99, precision score is 90, and area under curve is 95. So it's quite impressive stats of random forest. This is the curve of ROC curve of random forest. Confusion metric is that, which includes true positive, true negative, false negative. We can also use hyperparameter tuning here in this case, but we are not using it, taking a much more time for to cross validation in the cross validation, and 94% is a good accuracy score, so we don't need as basically. We don't require the hyperparameter tuning. The third and the last model we have used here is XGB classifier. Let me tell you that this random forest classifier and the XGBoost classifier basically is a boosting algorithm which which boost your model and increase your accuracy much more higher. But the XGB also has accuracy less than random forest, that is 81%. And the evaluation matrix is also the like curve of this is XGB is this just similar as of logistic regression. Confusion matrix is here. So this is basically a comparison between all the models. Logistic regression accuracy 71, 78, random forest classifier 94, XGB boost classifier 81. Recall 97, 99, 93, 70, 90, 75. Random forest is best among all the three. F1 score, this AUC. We can also recommend plots. Mm, so the question is, which evaluation metrics did you consider for the positive business impact and why? So recall, precision, F1 score, AUC. These all are the evaluation metrics we have used here. So after that, our whole conclusion of this model is, what was the conclusion of our model? Based on the performance metrics across different models, random forest classifier was selected as the final model. This model exhibited the best balance between the precision, recall, F1 score, and AUC, making the most reliable of the business impact. High recall means 99% ensures that almost all potential customers who would purchase vehicle insurance are captured, minimizing the loss of potential revenue opportunities. High precision means it indicates the most of the predicted positive customers are likely to be truly interested in this vehicle insurance. So so it takes less time to communicate with the customers, and it also minimize the marketing resources. High F1 score is basically shows a strong balance between the recall and the precision, which is a crucial when both the customer acquisitions and marketing efficiencies are important. So basically, this is our model. This is the model. I hope you liked my presentation. Thank you so much.